Hello, this is Matt with the Fitness Channel. We've got a bit of a longer video today because it's a pretty long topic. We're going to be discussing the muscular system. So as always, feel free to pause, fast forward, go forward to any topics in particular that you want to go through. But without any further ado, let's dive straight into those muscles. Here's a little mind map of what I'm planning on covering in this presentation. So we're going to start off figuring out the three main types of muscle which you're going to find within the body. We're going to describe the structure of skeletal muscle, so we'll figure out what one of those looks like. We're also then going to go through the different types of contraction that the human body might perform. We'll go through the roles that the muscles might perform, and then rather going through the name and location of every muscle, I'll just give you a bit of a revision tip on that one, and then there will be other videos which can help you on that. So this picture pretty much summarizes it. There are three types of muscle within the body. The cardiac muscle you are only going to find in the heart. You will not find cardiac muscle anywhere else in the body unless something terribly bad's going wrong. So cardiac muscle you only find in the heart. Smooth muscle, which is often referred to as non-striated, and the reason it's non-striated is it doesn't have, like skeletal muscle does, these little lines or stripes that run through them, and those stripes are actually the ends of each of the sarcomeres, which we'll talk about a little bit more in level 3. But the smooth muscle is non-striated. Cardiac muscle is just an individual muscle. It's not individual type of muscle, definitely not striated. Now your smooth muscle you will find in your internal organs. You will also find it in your arteries and some of your blood vessels as well. Now, if you ever see a question on your exam paper which says which of the following is smooth muscle, and it'll say heart, artery, or something like that, smooth muscle is what makes up your blood vessels. Cardiac muscle is only found in heart. Please don't make that mistake in your exam. Now, another thing to understand is that smooth muscle and cardiac muscle are classified as involuntary because you cannot consciously with your own brain control those muscles. So you can't send a signal and try to digest faster. You can't send a signal and make your heart beat faster. They are all involuntary. You cannot consciously control those muscles. Skeletal muscle, however, although there is a reflex action to it, it is voluntary. You can control those muscles. So if you send a signal to your arm now, you can pick your arm up. You can even make it wave. You can make it do a little dance. Skeletal muscle is voluntary. Now it's also striated or stripy. So if you dive into skeletal muscle, you notice all of these little stripes as they go down. They are striated elements of that muscle. They're the ends of each of the sarcomeres. So three types of muscle. You've got smooth, cardiac, and skeletal. So let's figure out what the skeletal muscle looks like. Now there is going to be a supporting video with this one showing you an activity that you can do at home to help learn this particular topic, but let's dig straight in and we'll have a little look. Here is what your skeletal muscle looks like. So what we've got here, we've got our bone. Attached onto that you've got a tendon. Tendons attach bone to muscle. Make sure you remember that one. And then what you've got here, if I kind of go into your arm and pull off your bicep, let's say for example this whole thing here is the bicep. So that is the muscle or muscle belly. Okay. Now if I was to go into that, it's basically made up of bundles. So the first group of bundles, which would, if I pull one of these out here, this is basically what we've done here. Okay, now what this is called is a fascicle. Okay, so if you get a load of fascicles, bunch them all together, you end up with the muscle belly. Now those fascicles have got inside them even more bundles. So inside that you're going to have your individual muscle cell or a muscle fiber. Okay, now inside of those you're going to have something even smaller called a myofibril and it's inside that myofibril where you're going to start seeing these sarcomeres. Now inside them, if we kind of zoom in, you'll notice that you've got these very small, thin, contractile proteins which kind of work, wrong colour, so you'll have something like this. Obviously not to scale, but what we're looking at here is actin and myosin. Now we'll learn what they do in a little bit more detail at level 3, but for now you just need to understand, if we zoom in to one of these myofibrils and have a little look down it, what you will notice is living inside these sarcomeres here are the actin and the myosin, and their job is to take the ends and pull them in towards each other by a theory called sliding filament theory. So we have our main muscle belly, we have fascicles, muscle fibers into myofibrils. Now I like to separate the next parts because it's a bit easier to understand, but surrounding each of those sections I've just described, you've got your own little coat. So it's a covering, it's a sheath, it's like a garment, use whatever phrase you want, get your own thesaurus. So you've got a little sheath or a coat which surrounds the muscle belly. You've got a little sheath or a coat which is surrounding each fascicle, and then you've got a little sheath or a little coat which is surrounding each muscle fiber. Now these all end in the word mesium or mysium, depends how you want to pronounce it, and you've got 3 of them. Now the reason they're there is obviously to give stability to the whole structure. If we didn't have that, there'd be no sections to it. And if you look at the other video where we build one out of cling film and string, you'll see why they're there in the first place. So if we start off, the one on the outside is called the epi. So that is the epimesium. They've circled it here for you. The one that surrounds the fascicle is called the peri. You just think of peri peri chicken if you really want to, and they've put that there for you. And then the one that surrounds your muscle fibers, the one at the very end, is called the endo. That's the endomesium, and that's what they've circled here. So I like to split that up into 2 phases. So the first one is to try and understand the sections. You've got your muscle belly, you've got your fascicle, you've got your muscle fiber into the myofibril. Then they all have their own coat. So you've got your epimesium, your perimesium, and your endomesium. A good way of learning that is to draw it out yourself. So if you go back to the start of this little section, find that picture of the skeletal muscle, or find one off of Google Images if you really want, and then try to label it yourself. Now, your muscles will contract in different ways. Now, I'm going to put a video together which shows an activity to describe this, but in a nutshell, a bicep curl is the easiest example of this one. If you grab hold of a weight and you lift that weight up, what will happen is that your bicep here will provide tension and it will shorten. So it will get shorter. That is what we refer to as a concentric contraction. Now, any concentric contraction, the weight will go up. So an easy way to remember that one is concentric contractions, the weight will go up towards the clouds. So C for cloud, C for concentric. That would be a good way of remembering that one. The opposite of that is if you take that same weight and you slowly lower it down, so you're not relaxed, you're actually providing tension, but you're providing tension, but you are lengthening the muscle. That is what we refer to as an eccentric contraction. So that's where the muscle provides tension and lengthens. Now, any eccentric contraction, the weight will be going down. If you imagine the ground or earth, you've got E for earth, E for eccentric. So easy way of remembering the difference between concentric and eccentric: in a concentric contraction, the weight goes up to the clouds. In an eccentric contraction, the weight will go down to the earth. Concentric clouds, eccentric earth. Now the other one they've thrown in there is what we refer to as an isometric, and that's where it's not moving. So if you take that same weight and you hold it halfway in the rep, you don't move it at all, this muscle is still providing tension, but it's getting neither longer or shorter. And that is what we refer to as an isometric contraction. Now it's pretty important to understand that, because if you look at programming a resistance training session for any clients, you're going to need to define a tempo for them. And one of the best ways to define tempo is to give them an amount of time to perform the concentric, eccentric and isometric contractions. Because a common mistake people make in the gym is that they're just performing reps for the sake of reps. If you break that repetition down into the eccentric, concentric and isometric, you'll get a lot more value out of that set. So 3 different types of contraction: eccentric, concentric and isometric. So we're going to move into the topic now of muscle roles. So we're going to define 4 main roles that a muscle may play in any movement. So I've specifically pulled up a door frame here because I find this is the best analogy to try and understand these 4 roles. So let's imagine that the movement that we want to occur in this door frame is opening of the door. That is the desired movement that we want to take place. Now, as part of that movement, different muscles will play a different part. So you'll have something called an agonist. Now, the agonist is the prime mover. Now, the prime mover in this example, if we were going to open the door, the best attachment site is going to be here. So an agonist would be attached on there, and it would pull, move, can do some kind of contraction, and the door would open. So the agonist is the prime mover. And in this example, it would be attached onto the handle here, and it would open the door this way. Now, if you imagine that there is another muscle on the other side, because most muscles work in pairs, because here's a key thing: muscles can only pull. Now, if muscles can only pull, we'd open the door. How would we get the door shut again? We would never be able to unless we were going to fight gravity. So if we wanted to get the door shut, we need to have a muscle on the other side who's then going to play the part of agonist. But in this example, when that door opens, if you imagine we've got another muscle attached here, and it's attached on back here and going on the opposite side, when this door opens, what would this muscle have to do? It would have to relax to allow that door to open. If it provided tension, if it pulled, they'd be fighting against each other and the door would never move, and that wouldn't be a very efficient movement. So the muscle which is on the opposite side of the lever, which relaxes, is called the antagonist. And the antagonist has to relax to allow the agonist to perform the move. So you've got your antagonist on the opposite side. Now, what you might also have is a muscle which is attached on here, okay, and it can pull in this direction. Now, it's not in as good a location as the muscle which is attached onto the handle here, but it's going in that direction. He might as well help his mate out. We would refer to these muscles as synergists. They're not performing the main action, they're not the prime mover, but they're going to help out because they're there anyway, basically. So the synergists assist. So the synergists assist the prime mover, but they're not the one doing the main movement, or they shouldn't be, as a note. Now, the last one that we're going to figure out, if you did imagine this was a door frame and it was just floating free in the middle of a room, as soon as these muscles started to pull, the whole frame would be wobbling from backward and forward, and there'd be no stability in the structure whatsoever. The frame would probably fall over. So what happens within the body is that you've got muscles which attach on to that door frame, and their job is just to hold on to it. So if you imagine we've got people at the side of the frame here, they're not actually performing the movement, so they're not actually doing the movement of opening the door. What they're doing is stabilizing this frame so that it doesn't move. They are called your fixators. So the fixators support the limb, the joint, whatever it may be, to prevent any unwanted movement in that desired action. And in this example, the desired action is opening the door. So in this movement we've got here, this example, opening the door, the agonist would be the one pulling the handle here. The antagonist, the one that has to relax, would be attached on the opposite side of the door. The synergist would be attached here, and the fixators would just be holding onto that frame to provide any stability and prevent any unwanted movement. Now if we wanted to shut the door again, the whole dynamic changes, because this agonist would then become the antagonist would then become the agonist. And this is constantly occurring, all in kind of synergy with each other. This is occurring all the way through the body. So something as simple as lifting your arm up in a bicep curl, your bicep would be the agonist, your tricep would be the antagonist. Okay? Oh, there we go. There's your muscle roles. So the four that you need to understand: you've got your agonist, you've got your antagonist, you've got your synergist, and you've got your fixator. Now then, for whatever reason, the free to use image of anatomical person is creepy eye man, so apologies for that. Now I'm not going to go through every individual muscle of the body. Suffice to say, I wouldn't spend an inordinate amount of time trying to learn every single muscle of the body, because in your written exam you might have 2 or 3 questions which require that knowledge. The other 47 or 37 questions, depending on who you're doing your exam with, are not going to include that knowledge. So if you spend 80% of your time trying to learn the exact name and location and muscle movements of a sternocleidomastoid muscle, you're probably going to be more efficient spending your time elsewhere. What I would do is you can go online. There's actually a little game called Poke Muscle. So if you pop that into your Google, other search providers are available. That little game is just a fun little game really, and that's one of the ways which helped me. Alternatively, if you go on and draw kind of a mindful colouring in book, you'll get a blank image of creepy eye man or another anatomical person, and then what you can do is actually colour in lovely pencil all of the individual muscles. Now I would split learning the muscles into 3 different stages. The first stage is to be able to take the name of a muscle, let's say for example deltoid, and if I was to say to you deltoid and you were to have a blank, so all of the muscles are kind of wiped out, and I was to say deltoid, you would be able to go, ooh, it's this one here. If I was to say, ooh, where is your glute med or gluteus medius, you'd be able to go, ah, it's around about here. Where's your glute max? Ooh, it's there, it is over there. So level 1 is just being able to name a muscle and point to a picture of a body and show where that muscle is. So if there's only one thing you learn, I suppose it would be that. If you want to level it up, if you want to go up a stage, you then need to define not only where it is, but figure out where it starts, so the origin muscle, and where it ends. Okay, so which is so you got your origin and your insertion. So if you can figure out where it originates, so its origin and its insertion, what you'll then be able to decide is what joint it crosses. So the next level is to be able to understand, ooh, there's our, what can we pick here? There's your triceps brachii. Okay, so the triceps brachii is there. If we level it up, the triceps brachii is actually going to be starting up. Well, in fact, most of the triceps actually start on the humerus. So the origin is the humerus and the insertion is going to be on the ulna. So that would be the next level up. So you figure out what the origin, what the insertion is, and then the last little bit would then be to define when that muscle contracts concentrically, what movement takes place. That's like level 3. It's like you've leveled up a whole level. So level 1 would be just to be able to get a blank with no words on picture like this, and be able to essentially join up the dots, so point an arrow to where each of those muscles are. Level 2 is to be able to say its origin and insertion. Level 3 would then be able to figure out what movements are taking place when that muscle contracts concentrically. Lots of different ways to learn that one. Like I say, I recommend using the colouring in because it's a bit more relaxing and a bit more mindful. Don't stress out about it. Try and learn as many as you can, but focus on other elements for your exam rather than learning that. So there we go. Well done if you stuck it out for 20 minutes. There's our little mind map again. What we've just covered in that presentation are the 3 main types of muscle. So we had our cardiac. Only one place in the body you're going to find that, and it is your heart. We had our smooth muscle, so this would be a smooth muscle there. They're all unstriated and involuntary. And then we had skeletal muscle. We then covered the structure of skeletal muscle down there. We figured out the different types of contraction. Don't forget your clouds and your earth. And then we figured out the 4 roles that a muscle will play in any desired movement. Didn't teach him, but there we go. Name and location of muscles. Just a little bit of revision tips for you. So good luck with all of that. I do hope you found this useful, and thank you very much for sticking it out with me, and I really look forward to seeing you on another video.